Good day everyone, I am Jeremy Camion Jr. from BS Ed English 1A. So in this video, we're going to discuss the mean, median, and mode of ungroup data under the measure of central tendency. So first, what is the measure of central tendency? So this is the summary measure that describes a whole set of data with a single quantity that is represent the middle or center of its distribution, the weight of each group of data that cluster around the central value. In short, this is the measure that tells where the center of the data set is located. The most commonly used measure of central tendency are the mean, median, and mode. So let's first tackle the mean. The mean is the average of a data set. It is also commonly used measure of a central tendency. So when we speak of average, we always refer to the mean. So we can use this formula, the summation of x over n. For example, the test scores out of 20 points, the students in a statistic class are 8, 15, 10, 9, 18, 6, 12, 13, 19, 20, 12, 14, 15, 6, and 5. What is the average score? So first, using the formula, we're going to get the sum of their scores. 8 plus 15 plus 10 plus 9 plus 18 plus 6 plus 12 plus 13 plus 19 plus 20 plus 12 plus 14 plus 15 plus 6 and plus 5 over 15. So why 15? Because that is from 15 students. So we're going to add their scores, so that is 189 and divided by to the number of 15 students and equal to 12.6. So the average score in the 15 student is 12.6. So 12.6 is our mean. Median is the middle of the set of numbers. Before finding this value, the data must be arranged in order from least to greatest. The median will either be a specific value or will fall between two values. But before that, if you have a given data and the given data is odd numbers, so it means you have only one middle data, and that is the median. For example, we have a 5 datas here below, and the x sub 3 is our median. Since the given data is an odd number and the x sub 3 is in the middle, it means that is the median. But if we have an even data, that means we have two middle values. So what are we going to do if we have two middle values? So we're going to add the both of them and divide it by 2. For example, find the median of the given data below: 23, 40, 78, 6, 67, 84, and 107. So first, to find the median, we need to arrange the data in ascending order. 6, 23, 40, 67, 78, 84, and 107. Since we have a 7 given data here, and 7 is an odd number, so we only have a 1 middle value, and that is number 67. And 67 is our median. Another example: 8 novels were randomly selected and the numbers of pages were recorded as follows: 415, 398, 402, 400, 420, 415, 407, and 425. Find their median. So we're going to do the same process what we did earlier. We need to arrange the data in order. So what I did here is I arrange it to ascending order. So I start to the lowest number and to the highest number. So let's count the given data. 1, 2, 3, 4, 5, 6, 7, 8. So we have an even given data. So what are we going to do since we have a two middle value, and that is 407 and 415? So we are going to add the middle value and divide it by 2. So therefore our median here is 411. Mode. Mode is a statistical term that refers to the most frequently occurring number found in a set of numbers. For example, the speed of 8 stenographers in typing per minute are as follows: 90, 111, 120, 116, 121, 124, 90, and 121. So what I did here is I arranged them to ascending order, so it is easy for me to identify the most frequently occurring number in this data set. In this data, the most occurring number is 90 and 121. So therefore, the data set has two modes, and that is 90 and 121. The dataset is said to be bimodal, so if we have a two modes, we called it bimodal. Another example: find the mode of the given dataset: 17, 98, 76, 54, 87, 90, 34, 23, 87, and 45. So we're going to do the same process what we did earlier. We need to arrange them in ascending order, but it is up to you if you're going to arrange it into ascending or descending. But in my case, I use the ascending order. So it is 17, 23, 34, 45, 54, 76, 87, 87, 90, and 98. In this data, the most occurring number is 87. So 87 is our mode. And the dataset is said to be unimodal since it has only one mode in that given data. So again, our mode here is 87 since it is the most occurring number in the given data. The last one is a weighted mean. A weighted mean is a kind of average, instead of each data point contributing equally to the final mean. Some data points contribute more weight than others. If all the weights are equal, then the weighted mean equals the arithmetic mean, or the regular average used to. It is also the number from x sub 1 to x sub n with the respective assigned weights. Mostly, we use this when we are computing our grades, especially in college, because in college, there are many units per subjects. So we can use this formula: x sub 1 times w sub 1 to x sub n to w sub n over w sub 1 to w sub n. And the x sub 1, x sub 2, and x sub 3 are the scores and their respective weights, and the w sub 1, w sub 2, and w sub 3 are the weighted mean of the scores. For example, Hannah's grade this semester: subject English 1, grade 1.7, units 3. Subject English 2, grade 1.3, units 3. Subject Statistics, grade 1.9, units 2. Subject Education 1, grade 2.3, units 3. And the last one is History, grade 1.6, and units is 2. What is the average of Hannah's grades? So we're going to use this formula to find the average of Hannah's grades. Weighted mean equals 1.7 times 3 plus 1.3 times 3 plus 1.9 times 2 plus 2.3 times 3 plus 1.6 times 2 over 3 plus 3 plus 2 plus 3 and plus 6. So the 1.7 is from the grade, and 3 there is from the units. Same with the denominators, in case that you are confused. Where did I get that? Because the x sub 1, x sub 2, and x sub 3 are the scores and their respective weights, and w sub 1, w sub 2, and w sub 3 are the weighted mean of the scores. And the sum of the numerator and the denominator there is 22.9 over 11, and it equals to 2.08. So that is our weighted mean.